Hi everybody, I'm Tony E at Show IP Interface Brief, and this is going to be a sort of a wrap-up video as well as a live lab session. Although this isn't being streamed live, I'm going to attempt a live lab, an uncut recording, and just go through from beginning to end. And why I want to do this is I've actually learned a bunch of things while labbing today. I've been focusing on Dmvpn using Ipv4 and Ipv6, and there's some subtle nuances that I wouldn't have seen otherwise. This has helped me get a better understanding of Ipv6 addressing, as well as the specific configurations for NHRP. As well as while I was doing these labs, these exercises, I've been sort of building up. I did a simple topology, a little bit more and a little bit more. And so now actually I'm going to try something that I just kind of thought of and I wasn't sure if I can do it or how to do it or if it's been done. So I wanted to go ahead and do that live. A couple of things. I did not upgrade to EVE-NG Pro, not yet. I was thinking about doing that today since I had more time being a holiday, but I've just been labbing nonstop. So that might be something I do in the future. So one of the things I don't have working is the Wireshark capability in EVE-NG, and I really lean on packet captures pretty heavily, which is why I sometimes prefer GNS3 because I can dump straight to a file on the desktop, no problem. I know EVE-NG has like a Wireshark wrapper and uses a PuTTY and P-Link and stuff like that, and I have never been able to get it working. I haven't tried very hard, but it didn't work out of the box, and that's about as much patience as I had for that. So let's go ahead and get started. So on the screen here is my EVE-NG topology. I got router 1 on the left, which is going to be my hub. Router 2, 3, and 4 are going to be the spokes, except let's dive into this a little bit more. Let me open up a whiteboard and you'll see what I mean. Let me grab a black color. Perfect. Router 1, router 2, router 3, and router 4. And they're all connected via a non-broadcast multi-access. And here's what I'm going to try. Here's something new. I haven't done this before. I don't know exactly how it's going to work. I have an idea. I have a hypothesis. So on how to go about the configs. So this is going to be me. I'm trying it live. Here's what's different about this. This is a pretty standard Dmvpn architecture that you'll see in any example architecture or lab architecture. So what I'm going to do here is this is the hub. So I'm going to call this the Ipv4 hub, and which means these are all spokes. And so I'm doing this in red, which means this is a spoke. It's going to go to the hub. This is a spoke. It's going to go to the hub. And this is a spoke, which is going to go to the hub. Here's where I'm going to do things a little different. I am going to do a dual stack Dmvpn, except I want to change it up a bit. I want router number 4 to be the hub for Ipv6, which means router 3 is going to be a spoke going over to the hub, router 2 is going to be a spoke, and router 1 is going to be a spoke. So that means here we're going to have an Ipv6 reachable network, and routers 1, 2, and 3 are all going to register with router 4 for Ipv6. However, on the Ipv4 architecture, routers 2, 3, and 4 are going to register with router 1. Now, why would you do this in the real world? I don't know if you ever would. I just want to know if I can, and sort of what those nuances might be. This is why I love labbing so much. Anytime for work where someone has asked me to, if something's going to work or if it's not, and if I'm not sure, I come home and I lab it up. And it's normally not crazy stuff like this, but that's how I've gotten the most. That's how I've learned the most. And that's why I'm so excited about labbing today. I was very successful with some earlier labs, so let's dive right in. So I have a couple of terminal sessions open here. I've been labbing already, so again, if we look at router 1, if I do show Dmvpn, you see I already have some clients registered. So I'm going to start with a clean slate. I have a startup config, so if we do show startup config. It's pretty basic. In fact, it has only an IP address on the gigabit 00 interface, as well as no IP domain lookup and logging synchronous on the console lines. That's it. So let's get that config in there. This might take me about 30 minutes to do this whole lab. So I'm not going to do any more updates. This is going to be purely a learning session and an exercise to see if I can keep up. Y for yes. I'm over on router 2. I'm going to paste that in. Y for yes. And I think over here, router 3, enable, paste this in. I think I can do force. And router 4, enable, paste, force. So the reason I went ahead and did this configure replace command, it's actually something new to me. It's not new to Cisco. It's no secret or anything. But what it does is when you actually do, let's say you're working on a lab topology and you want to go back to the startup config. If you do copy startup config to running, that's actually going to do a merge operation. And so what that means is it's just going to go ahead and bring in any configurable command elements that weren't previously in the config, the destination config, and it's just going to merge that. So it's not going to clear anything away that you already have. If you do the configure replace, it's actually going to add in everything you don't have and remove all of the elements that aren't in the source config. And that's why I do that, because as you can see, now I'm back to square one. So I do show IP interface brief, and I have only the one interface configured. I don't have any protocols or anything running, but I did previously. So that's a much quicker way to sort of revert back, because if I was to do a erase startup config and reload, or just a reload and have it pull from the startup config, it would actually take, I don't know, about a minute for each router. And although it's taken me a minute to go ahead and explain this, it's just quicker. So I want to get in the habit of doing that for my labs. Okay. So first we're going to establish the IPv4 Dmvpn with encryption. And so the encryption part is what always throws me for a loop. I don't have all of the commands memorized. I can't write them out as seamless as I would like. But let's do a couple of things. I'm going to open a fresh notepad and start writing configs over here. So first thing I want to do is I want to introduce a loopback on routers 1, 2, 3, and 4, and just give it a quad address of the router ID. So router 1 will be 1111, and router 2 will be 2222, and go ahead and configure that. And then I'm going to start with building the crypto configuration, because we can paste that in without actually enabling it, and put that on all of the routers necessary. And then we'll build the DMVPN, which is the tunnel architecture, and then we'll do routing protocol. And then we'll do the same thing for IPv6, except we won't have to do the crypto again. And that's one of the things I wanted to show you. Okay, so at the top here, we're going to do conft interface loop 0. We're going to call it IP address and give it a quad address. I always do a no shut on loopbacks, and that's because I was in an iOS Cisco architecture one time, and when you configure a loopback, it doesn't actually no shut it. I can't remember what OS that was, whether it was Nexus or iOS XR or what it was. So I always do no shut. All right, we can go ahead and put this on all of them. So actually what I want to do is, while I'm here configuring IP addresses, this is kind of the basic steps, I want to go ahead and configure our IPv6 address on our gigabit 00 interface. That is going to be our NBMA, non-broadcast multi-access address. Right now, each gigabit 00 has an IPv4 address. We want to go ahead and add in an IPv6. For that, I'm going to use a global unique address. First, let's turn on IPv6 unicast routing interface gigabit 00, and we want to do IPv6 add. I'm going to do 2001::1, and we'll do /48. So what I can do is paste this in. If it goes in, no problem, great. I'll bring this over here, open up my other terminals, and if I just change a couple of elements here, this is something that I wanted to work on, was how quickly can we do this? Okay. Router 3. And then router 4. So I'm kind of going to be doing a little configlet here and then pasting it in. That's how I do it. I do it one at a time. I don't like to paste in the entire config, especially this one is going to be a long one, because if there's a mistake at some point higher up in the config as you're working through it, you might not catch it. You might not see the error message in the console screen. Okay. Next, I'm going to do a little TCL script. I've seen people talk about this on the CCIE lab for verifying connectivity at the end. Some people have said you don't have time to do it. Some people said it's definitely recommended. I'm going to do it here just because I want to stay sharp on exactly the command. So that's TCL-SH. And then here's how I like to do it for each address. And we're going to do each of our IPv4 and IPv6 addresses, 172.172.17100.3, 172.17.100.4, and here ping address repeat 3. If we haven't tried to reach that address before, we'll lose the first one to ARP. So I just do it repeat 3. Let's see what happens. All right, looks like everything's reachable. I'm going to go ahead and do the same thing for IPv6 because we did just put some global unicast on there. What were the global unicasts? : 1. And we got to do ping IPv6 address and then the repeat value, which I like to do as 3. We don't have to do this on every router, at least on this test here, because if router 1 can reach everything and you get a successful reply back, that means traffic can come back. We know we don't have any ACLs or anything on yet stopping the return traffic. Okay, so that validates IPv4 and IPv6 connectivity in our NBMA network. So now let's start working up the crypto configs. Let's see if I can remember all of them. First, we want to do an Eigrp policy and give it a policy 1. That's really the order of I would say importance, order of importance. Okay, and for this one, if we don't put any values in, it will take default values. The only one I want to do is authentication pre-share. I'll do exit after that because that's a sub-configuration mode. The next one is going to be we got to do our transform set. So let's do our key. Excuse me. Pre-share, and let's say our key. Crypto key. Am I thinking about this wrong? Crypto Eigrp key. Uh-oh, now you're throwing me for a loop. Crypto. I gotta type that into a console. Here I'm on router 2. Let me exit out of that. Crypto key, no. Crypto authentication, no. Crypto Eigrp key, that's what I'm looking for. Crypto Eigrp key. I'm going to put the key in, which I'm going to use Cisco. I guess, you know what, maybe we can do something funny. Crypto key, and then we're going to do and we're going to apply this to everybody. I think that's going to be the format. Okay, so now we're going to do crypto Ipsec transform set, and I'm going to call it my trans, and the values I'm going to put in there, and then I'm going to do I can never remember all of the values. In fact, I have here a whiteboard of things that I want to work on, and one of them is my crypto. And here's our options here: ESPAES, and then I'll take that SHA-256 HMAC. I'll throw that in there. Okay, and then we're going to do crypto Ipsec profile Dmvpn set trans my trans and then let's paste this in. Like I said, I like to do one little chunk at a time. I don't know if it's the best way. Give me some feedback. Let's see. That went in. Excellent. So although it took some time to write it up, I only had to do it once. Let's just hope it's right so I don't have to make 4 corrections. One thing I will point out, and we'll go back to this if not, I'm doing a crypto Eigrp key, and here's the pre-share key, and I'm setting it for the address, and this is an IPv4 dotted decimal address. When we do the IPv6, we will need to change this, or rather we will need to add an element here for it to work. All right, so let's go ahead and start our tunnel interfaces. So I'm going to do 2 templates. One is going to be for the hub, and the other is going to be for the spokes. I'm going to do interface tunnel 0 for the IPv4 Dmvpn tunnel. IP address, I like the 10 space, and I just like to go 123 and 234 and 1. I'm going to give it a /24 mask, and I'll separate that. Okay, now there's a couple of elements we need for Dmvpn at the hub. Since this is IPv4, we're going to do IP NHRP map multicast dynamic, and that's so it will dynamically register and map multicast to the register packets it receives. Let's give it a network ID, IP NHRP. Network ID, we'll call this one 1234, since it's routers 1, 2, 3, and 4. And then we want to do tunnel source. And I actually want, in most instances, you will specify an interface here. In most examples, you will see. But I was thinking about this before I started this lab, and I think I actually want to specify an IP address. I don't actually know how this will affect me in the long run, but I'll try to walk through what my thinking is if it doesn't work here. So I'm just going to specify our interface IP address. And tunnel mode, we're going to be GRE multipoint. And one of the last things for our encryption, we're going to do tunnel protection, Ipsec profile Dmvpn. Okay, that's for the hub. Now the spokes, I'm just going to grab this. We're just going to add a couple of lines and replace some mappings. So in the case of the spokes, I'll start with router number 2. We need to change this mapping here, so we're going to do, excuse me, map multicast. We want to send that over to R1's NBMA. We want to do IP and HRP. We want to map the NHRP address to an NBMA address, and we want to set a next hop server, which is going to be the NHRP address. Okay, our tunnel source here. Here I'm going to use the source IP address of each spoke. And again, this might work, it might not work. We'll see. So let's go ahead and paste in these couple of elements here, and if it goes well, then I'll go ahead and finish up the other spokes. Okay, tunnel mode GRE multi. Multipoint. Which means I'm going to have that same issue here because I copy and pasted it. So let me come over here on router 2, paste this guy in. That went well. All right, let me change that to 3, change the source to 3, grab it, paste it over here on router 3. And this is one of the beautiful things about Dmvpn. I told you guys I really love this this technology. It's really cool. There's really once you build the template, it's minimal changes for your spokes. All they did was just change one character in the line. It worked out pretty well. Okay, my tunnel states are up. Let's hope they stay up. I'm going to go ahead and put a line under this. Okay, so now we should be able to reach our tunnel interfaces. So let's do do ping 10 1232341 and source from tunnel 0. That didn't work. I just want to check to make sure I gave myself the 4 address, and let's see. We should have registered. Let's check it out. I was hoping I didn't have one of these failures, so I'm not wasting anybody's time. The Dmvpns show that nothing is registered. Looks like crypto is on. Tunnel states are up. We can do... I don't see any registration requests on here. Let me look at the configuration again. Wonder if I'm missing something there. Got my network ID. All right. I can still reach ping 172. See if I can reach the NBMA source gig 0. Yeah, that's still there, but I can't reach the. Let me turn on debug IP packet. I just did debug IP packet, trying to see what's going on here. Looks like classification R type for us false. Source and destination tunnel. Okay, it's going out the gigabit interface. So I want to come over here and do debug IP packet. I want to send that ping again. It looks, I'm seeing a packet from router 4 routed via the rib. Okay, it's statically configured. Did I fat finger the address? I'm actually going to take a look at the running config for the interface to make sure the elements are configured properly. I tell you what I'm going to do. They should have registered. Let me go over. Let me try that again, because looks like the routers are trying to reach out, but when I send the ping, looks like I'm getting something here. I want to see if there's anything. This is my the configs that I was working with earlier today. I just kind of, for the sake of saving time, because I really want to try the other part. This part should have worked already. Maybe. Crypto Ipsec Dmvpn. I'm going to push forward and try to configure a basic Eigrp for the tunnel interfaces, just so I'm generating some of that multicast traffic across there. I want to do, excuse me, I want to type it in here. Router Eigrp 90. No auto. Passive default, no passive interface, tunnel 0, no passive interface, loop 0. Network, all of them. So I made a mistake in my template. Hammer this in. Okay, which part isn't working here? NHRP map multicast. The source and destination should be reachable. Mode, GRE multipoint. Uh, 172.17.100.4. I tell you what, let me take the crypto off. I don't know why I didn't think of that earlier. Let me take the crypto off and then see if we get any join messages. Okay, interface tunnel 0. Maybe I shouldn't have done it to all of them. Maybe I should have just done it to a pair of them, a hub and one spoke, and then see if it comes up. Okay, that ping worked. Let's see. Okay, now they're starting to register. Looks like it's probably a problem with the crypto. What have I done to screw up the crypto? All right, all three of the clients are registered. I didn't see any Eigrp adjacencies come up. Let's do show IP protocols, Eigrp. Show IP Eigrp interfaces, loopback and tunnel. Do I not have Eigrp on this thing? Show IP protocols. Eigrp 90, I do. So I'm going to pop into the running and see what the configuration is. Should be good. Passive default, no passive tunnel, no passive loopback, and I forgot a network statement. There we go. Now we got adjacencies popping everywhere. All right, let's revisit the crypto. Let me look at it on the hub. Let me look at the actual configuration and make sure none of the elements errored out when I pasted them in. So I'm going to do show run and just take a look at the beginning. Okay. I tell you what, I'm going to take a look real quick at did I give myself IPv6 addresses on here? Show IPv6 interface brief. I did on gigabit 0. Let me try this. Crypto, Ipsec key, address IPv6, and let's go bang bang. And I'm just going to try it on one spoke here before we get too far ahead. I'm wondering if it's actually using the IPv6 addresses. I don't know why it would. I'm just grasping here. Okay, so interface, tunnel 0, tunnel, protection, Ipsec, I believe it's profile, Dmvpn. Okay, Eigrp is on router 2. Eigrp neighbors 3 and 4 are down for the hub. But not for router 2 yet. Okay, neighbor's still up. I'd say what I'm going to do. I'm actually just going to take off the tunnel protection and put it back on. Okay, router 3, I just took it off to put it back on. And adjacency came straight up. Router 4. Excuse me, no, I'm going to paste that in. Adjacencies came right up. Let's give it about 10 seconds. See if it's going to stabilize. Make sure it's not flapping for any reason. Wow, that was tough. Throwing me for a loop. I don't know what the hell's going on. Take off the tunnel protection, rip it back, put it back on. It's things like this that could be sort of frustrating. I try not to let them be setbacks, but you really don't understand. I gotta take it off, put it back on while that matters. I know it happens like that a lot in production, but you know, when you live in this lab environment every day, day in and day out, it's funny when, you know, I've done this lab 3 times already this morning, at least the IPv4 portion. But I guess it's working now. Okay, so over on router 1, let's see if we're getting all of those loopback interfaces from the spokes. Show IP route, check the routing table. Looks like I'm getting the 111, 222, 333, and 444. 111 is our local. So let's do and source it from loopback. Okay, we can reach across there. Now let's come over to router 4, show IP route, and it looks like I can only see 111 and our local is 444. And I bet over here we can only see 111 and we can see our local, so we're missing 2 and 4. And on this one, show IP route, 111 and 222. This is of course because of split horizon. So I did know this ahead of time, but I wanted to go through the exercise in case anyone's watching this, learning this. So let's get into the interface tunnel 0 and do no IP split horizon, Eigrp, and our autonomous system number. Should see the adjacencies bounce. And if we go over to any of the spoke routers, we should see the full routing table. Okay, excellent. So I wonder if I can ping now from, of course that's myself. Okay. Okay, so this I believe this is actually going to be going through the hub. It is, yeah. So I'm going to do a double trace route, hit it once, hit it again, and it's going through the hub each time. And that's fine. That's because we're not, the next top value is the hub, and so packets are always going to be forwarded towards the hub. That's fine for this lab because I really want to get moving on the IPv6. Okay, so if we go back over to the whiteboard, what we've just done was the elements in red. We went ahead and configured the hub router. The spokes are done, and we have spoke-to-spoke reachability, except it goes through the hub first. And that's perfectly fine. That's valid reachability as far as I'm concerned in this lab environment for as deep as we're going to go today. Next, I want to start on the IPv6. And again, this is something I haven't done before in this manner. I have done the dual stack Dmvpn. I've been doing it all morning. And this is the new thing that I wanted to try. So let's go ahead and make router 4 the IPv6 hub and the clients around the board. So let's bring up our notepad and start some configs. I don't remember which is which. I think this is my notepad from earlier, not the one I was just typing on. This is the one I was just typing on. Okay. So first thing is, let's go ahead and create a new loopback. Loopback 6 for IPv6, and let's give it a unique local address. So do IPv6 address, and we'll call it FC. This case is it's router number 4. So let's go FC04 4. And in case we didn't already, I think we did. Let's check. Did we turn on IPv6? We did, and we can verify that. And our gigabit, our NBMA interface already has a configuration. So let's do, I think we can just type this out. I don't know if it's going to save us any time. And FC03. Maybe it is saving a little bit of time. FC02. There's some console messages telling us our new loopback is up, and config t interface loopback 0, IPv6 address, FC01:1. All right, this is just a loopback, so we can work on sharing this loopback with the other spokes and with the hub via a routing protocol across a IPv6 Dmvpn tunnel architecture. Okay, so one of the next things we're going to do is we're actually going to create another tunnel. So let's do interface tunnel 1. Let's give it a unique local address, so IPv6 address, and let's call it FC, and this has to be a shared subnet across all of the hub and spoke. So let's do 1234, and this will be number 4, and this will be a slash. We can do 64 will be fine. Okay, and one of the, if you remember what an interface tunnel stanza looks like, the tunnel commands are at the bottom. So let's do tunnel source, and this is why I specified the IP address to begin with. We're using the same physical interface. So in a typical design, you'll see tunnel source gigabit 00 for a Dmvpn examples. But I want to use that same source for two different architectures. So I wanted to specify IPv4 on one side and IPv6 on the other. So I'm going to do 2001, I think it's ::4 is my source here on, would be router 4, which is going to be our hub. And I'm going to do tunnel mode GRE multi IPv6. Okay, one of the requirements for doing this per the Cisco design documentation is you also need to create a link local address. So let's put that in here. Let's call it FE80 and bang bang 4, and then we got to do the link local keyword. So that will specify the mask, which should be 68. Okay, so let me go ahead and put these addresses in for each one. Router 3, router 3, router 3. Router 2, router 2. It's a lot of repetition. That's why I put multiple spokes in there, so I go through the repetition, so I go through the practice. I'm trying to race against the clock because I think my family's coming home soon, and I want to finish this. I hate when I have to walk away from the lab, but sometimes you just have to. Okay, so now we got that. So let's start working on the NHRP stuff. So let's take a look for our hub. Similar configs, except everything is going to be IPv6 NHRP. We're going to do map multicast dynamic for the hub. Let's do IPv6 NHRP. NHRP network ID. Now I think we have to do a separate network ID here. I don't actually know if we do. We might still be able to use 1234. I'm going to use a different one if it'll take a number, a value that high. I'm going to give that a try. And there was another thing in the Cisco design documentation I just remembered. It said to turn on redirects, NHRP redirects. And it said to use shortcut on the spokes. So now that router 4 is our hub, we'll use redirects. And then here on the spokes, we want to do IPv6 NHRP map, and we want to map our unique local NHRP address, our tunnel interface, to the non-broadcast address. So that's going to be FC001234, and it's going to be 4. I think we did 64, and then that's a mouthful, isn't it? NHRP map multicast, and we're going to send that to our NBMA, and then IPv6 NHRP. Next hop server is going to be our unique local. So it's just a matter of sort of juggling all these IP addresses. IPv6 NHRP shortcut. So as long as we're in the correct interface, we should just be able to bang this in on all of them, because the configuration doesn't change. It's all just mapping and pointing to the hub, which is IPv4. Okay, so let's take a look at our IPv6. It's an IPv6 exercise. Let's take a look at our IPv6 interfaces. Show IPv6 interface brief. Our gigabit interface, which has our global unique, our tunnel interface, which has our unique local, and then we also have a unique local as a loopback. And the tunnel interface also required a link local. So let's see, show a Dmvpn. I don't know if that's going to show me IPv6, but we can do show IPv6 NHRP. It's not giving me what I want here. Oh, and you know what? We got to do I think tunnel protection. Except I want to do interface tunnel 1, tunnel protection, IPsec profile, and Dmvpn. We can use the same profile, right? Because none of them are specific to one stack or the other, IPv4 or IPv6. And as long as we put that key in there that matches both addresses, or you could have separate keys for separate stacks. Tunnel protection, IPsec profile. I probably could have pasted it in, try to save time. Okay, I'm not getting any registration. So let me go around. I'm going to start router 1, 2, and 3 and start turning on Eigrp. And see if we can finish this lab up. Let's do interface loopback 6, IPv6 Eigrp 6, interface tunnel 1, interface tunnel 1, IPv6 Eigrp 6. And you know what? I think I can speed that up. Yeah, that's definitely not going to work the way I wanted it. And then one of the last things is router. And this, I'm actually specifying a name. This is not a stack ID or anything. I'm just naming my routing process, Eigrp routing process, Ipv6, because I like to. Now you'll see here I'm forming an adjacencies, and I actually know that this is a problem because I did it earlier. I'm forming an adjacent 6 adjacencies on 3 adjacencies on each router, which means each spoke should only have 1 adjacency, and that should be the hub. So that tells me that this is actually using the NBMA addresses. So if I do show Ipv6 interface brief, I can see they all sort of fall in this scope here. So under the Eigrp address family, I want to do interface gigabit 00, and I want to do shut. And that will shut down the routing process for that interface. And I'm just putting it on each router. I actually want to take a look at the running config for that tunnel number 1 interface. Show run interface tunnel 1. Let's see what I might be missing here. I wonder if my mappings are wrong. 64. 2001. Okay, again, I guess I will I try to rip off the tunnel protection and put it back on. I'll do it here on router 3 and 4. And just see if okay, so an adjacency came up. That's exactly what we were looking for over the tunnel interface. Let's see if we put it back on. If the adjacency will go down. Yeah, it did. It went down. So I'm just going to go around the board and remove it from all of them. I want to see those adjacencies come up. So I see router 3, router 2, and hopefully router 1. So Okay, let's take a look at the routing table. Let's see if we learned anything. No, even though it says I have an adjacency. Time expired on neighbor 3. 3 and 2. Looks like they're bouncing. How can I verify this? Let me take a peek at that show run. You know, I try to restrict myself from doing it. And although I've done it many times through here, not nearly as much as I normally would. Hey, I wonder why I don't see the key here for the IPv6 address. Maybe that's my problem. Let's take a look. Show run. If it is, man, I'll paste that thing in. That's got it. That's what I'm looking for. Let's grab this thing. Okay, so it has it on there. What am I doing wrong? And I want to take a look at the tunnel configuration, because I can't remember which router has the tunnel protection and not. Just taking a look at the config for that interface. So let me do tunnel protection, Ipsec profile, Dmvpn. Let me grab it. Just pasting it around the board. I would have expected to see it come right up already. I don't know. I have to go back to the drawing board on this one. Like I said, I wanted to try a configuration I've never done before. I did okay. I was more successful earlier. I didn't do this configuration earlier. But I did do a dual stack, so IPv4 and IPv6 using the same hub. What I wanted to try was separating the hub, so an IPv4 hub on one side of the topology and an IPv6 on the other, but using the same underlying transport. So looks like I got to go back to the drawing board, see what's going on here. Something's not working properly, and so I need to troubleshoot it, maybe do a little reading, and take it from there. So anyhow, I'm gonna leave it. It's in the afternoon. I'm gonna leave it like that. I don't think I have anything else to cover. Thank you all for joining me in the journey. This has been about an hour and 15 minutes, I think. I'm not gonna edit this video. I'm just gonna throw an intro on and upload it. So thanks for your time if you stuck with me this long. and I hope to see everyone labbing here soon. And if I get a solution, I'll go ahead and just do a quick solution video to whatever this problem is, if I have one. We'll let time decide. Thanks, guys. See ya.